So for this lesson, you will learn how to solve quadratic equations by taking the square root. So this was the purpose of the lesson from yesterday. That is to show you how to solve equations when you have only two terms, okay? So the plan, step number one is what you've done before. We need to isolate the quadratic. So that means the x with the second power. Okay, so that's step number one. Step number two, we are going to take the square root of both sides. But I'm going to mention something that I mentioned a few weeks ago, that whenever you take the square root, if the index of the radical is even and the power of what's coming out is odd, then you must include absolute value. Okay, so I'm going to write that here. So once you take the square root, then you write the absolute value. And when you remove the absolute value, this implies that you got to have plus or minus, okay, in front of whatever is on the other side of the equation. So that's too many words to do what I'm going to do next. So the first example, I'm going to move this -4 to the other side. So then that gives me the x squared by itself on this side, so it's isolated. But this 4 now becomes +4. From there, this is step 2. I'm going to take the square root. Okay, so then the square root cancels the square, so then this gives you the absolute value of x is equal to +2. Again, because the index of this radical is even, the power of this x is odd, which is 1, so that's odd. So once you remove the absolute value, then you have to say the following: plus or minus, in this case, 2. Okay, and this has the two solutions to this quadratic equation. Let's go to example number 2. Same thing. I'm going to move this 36 so I can isolate the x squared. So then we have x squared equals, this becomes +36. Then the x squared is isolated, or the quadratic is isolated, so then we take the square root. So when we take the square root, we get the absolute value of x is equal to 6. And when I remove the absolute value, I have to say that I have two solutions here, which is plus or minus, okay? I don't know if you guys remember this, but the absolute value deals with distance. So 6 is at a distance of, 0 is at a distance of 6 from 0, and so it's -6. So that's where that comes from. Okay, example number 3. I'm going to move this 2 to the other side of the equation, so that means I'm going to add that 2 to the 64. So then this gives me 9x squared is equal to 64. Because 2 plus 62 is 64. Then I need to isolate the quadratic, so I'm going to divide by that 9 on both sides of the equation. So then this gives me x squared by itself. So then this is 64 over 9. What I'm going to do next is to get rid of the square. I'm going to take the square root of this side, also the square root of 64, and the square root of 9, because they're both perfect squares. So then this gives me the absolute value of x is equal to, square root of 64 is 8, and square root of 9 is 3, right? I was gonna write a 9, which is wrong. So 8 over 3. Then when I remove the absolute value, I have to say that this is equal to plus or minus 8 over 3, and this has the two solutions to that quadratic equation. So notice this one was a little bit different. Example number 4, I'm going to move this -144 to the other side, which means it's negative on this side becomes positive on that side. So then we have 12x squared equals 144. Again, see in general, so what we do is we divide by this 12 on both sides of the equation. So then that gives us the x squared isolated on the left side of the equation, and 144 divided by 12 is equal to 12. So then we take the square root. So So that gives us the absolute value of x is equal to, I'm going to take this to the side and simplify it. So the square root of 12 is the same as 3 times 4, but 4 is the same as 2 times 2, right? And 9, I know this looks like a 9, but it's a 4. So let me make it look like a 4. So then we can take out a 2. So then a 2 comes out, and the 3 stays inside, okay? And once I remove the absolute value, then I say x equals plus or minus 2 square root of 3. And that's all we can do for this equation. And there you have the two solutions, the plus and the minus. Let's go to example number 5. Again, the process is the same. You want to isolate the quadratic. There's a minus 30. So let's move that 30 to this side. So then we have 5x squared is equal to 30. Then, so once you move that 30 to the other side, let's divide by 5 on both sides of the equation. So then this gives us the x squared is equal to 30 divided by 5 is 6. Then to get rid of the square, we take the square root. Okay, so then this is the absolute value of x is equal to the square root of 6. Now 6 is not prime, but the only multiples of 6 are 3 and 2. There's only one of each. We can't simplify it. So then we just leave it as it is. Just include the plus and the minus in front of the square root. So these are the two solutions to this quadratic equation. Next example, example number 6. Notice the difference in this one here. There is parentheses and the quadratic or the square is outside. But the process is the same. Let's move this 10 to the other side of the equation, so it becomes positive 10. And on this side, we have x minus 5 squared. So once we get the quadratic by itself on one side, let's take the square root to cancel the square. So then this gives you the absolute value of x minus 5 is equal to the square root of 10. Again, 10 is not prime, but the multiples of 10 that are prime are 2 and 5. There's only one of each. We can't take anything out. So then let's remove the absolute value. X minus 5 equals plus or minus the square root of 10. Now we want to get the x by itself. Let's move this 5 to the other side of the equation. So then that gives us x equals 5 plus or minus the square root of 10. So this has the two solutions for this quadratic equation. Again, so you're taking the square root again and again on every single problem, okay? So that was the point of the lesson from yesterday, so you could see that the square root and the quadratic are inverses of each other. That's what you see on the graph. If you look at the previous page on the notes packet, that's what the lesson was about. So for example number 7, I'm going to move this 6 to the other side. So we have negative x plus 3 squared equals negative 6. There's a negative 1 implied. I don't want this to be negative. I'm going to divide by negative 1 on both sides of the equation. So then that makes this positive quantity of x plus 3 squared is equal to positive 6. Okay. Then we take the square root to cancel the square. So then this gives us the absolute value of x plus 3 is equal to the square root of 6. But then once we remove the absolute value, we have x plus 3 equals plus or minus the square root of 6. Then we move this 3 to the other side of the equation. It's plus here, becomes minus on the other side. So then x equals negative 3 plus or minus the square root of 6. And this has the two solutions to that problem. All right. For example number 8, there is a positive 8. I'm going to move that 8 to the other side as well. So it's similar to number 7. Let's move this 8 to the other side. So then it becomes negative 8 on this side. But now we have negative 2 times the quantity of x plus 1 squared is equal to negative 8. We need to divide by negative 2 to get rid of that negative 2. So then this gives you x plus 1 squared is equal to 4. Once we have this isolated, let's take the square root so we can cancel the square. So then that gives us the absolute value of x plus 1 is equal to 2. Then let's remove the absolute value. So then x plus 1 is equal to plus or minus 2. And then we move this 1 to the other side, so it becomes minus on this side. So I'm going to do the following. So x equals, this has the two solutions, and they're just going to be numbers. One is negative 1 minus 2, and the other is negative 1 plus 2. Well, negative 1 minus 2 is negative 3, and negative 1 plus 2 is positive 1. So then x equals negative 3, comma, positive 1. So these are the solutions to this quadratic equation. Okay, so that's all for this lesson.